This is a continuation of section 18.3, spontaneous reactions. I just realized that my iPad had full storage and I was not able to continue doing any more video. So we're going to continue where we left off at melting ice. Again, this is an endothermic reaction. So if you can write this reaction down, when you take ice and you add some heat to that, heat going in being an endothermic reaction, it's going to melt into water. So again, melting ice is not an exothermic reaction. Heat doesn't come out. You have to put heat into the ice. It's going to melt it into the water. So we're starting off with a water solid and melting it into water in a liquid form. If you look back here, we're comparing the three phases, solid, liquid, and gas. Solid has a nice crystal pattern. It's organized, it has structure, it has order. That's where we are with the ice. It's a crystalline 6-part honeycomb. And when you add heat to that, it's going to melt it into something that's more chaotic, much more simpler. So, however, with this is, because it's more simpler, we're increasing the entropy. We're increasing the chaos. So we actually have increased entropy in this case. If you look at the previous example with the burning of the coal, yes, it is exothermic, but what's happening as well is take a look at the number of atoms that we have. We have 2 particles here, 1 and 2, and we're combining that into carbon dioxide. We have something that is now 1 particle. We're getting something that's more organized. We're taking the 2 smaller pieces and building up to something bigger. This actually is increasing the complexity and therefore is going to decrease the entropy. So if you can go to the back side of this, we're going to look at and compare a spontaneous reaction versus the non-spontaneous reaction. What makes the spontaneous reaction happen? So you can imagine that this is sort of 0. This is where no reaction happens. And if we're anywhere in this area, this realm, kind of like a number line, these are the positives, these are the negatives. Over on this side, this is going to be a spontaneous reaction. Over in your negatives, this is going to be a reaction that does not occur. So again, there's 2 factors that make something spontaneous, and it's going to be heat and entropy. So what type of reaction will make a reaction that's going to be spontaneous? It's going to be an exothermic reaction. Exothermic reaction. Also, by increasing the entropy, increasing the chaos, this is the tendency for things to go towards disorder, like your room. It's the natural state of things. They're tending to decay. They're tending to break apart. That's the natural tendency for things. That's the entropy. We're increasing the entropy. Those 2 things, those 2 factors will push a reaction to go forward. What's the opposite of an exothermic reaction? Is an endothermic reaction. An endothermic reaction will slow a reaction down. What's the opposite of increased entropy? It's decreased entropy. If you're making something that's more complex and stable, that's going to be harder for the reaction to occur because it wants to fall apart into its natural state. If you have both endothermic and a decrease in entropy, that's going to halt the reaction. It will not go forward. It will be a non-spontaneous reaction. So we're going to go back to our 2 examples, and we have the charcoal example, and we have the melting of ice. Neither of these is both exothermic and increased entropy, but we can burn charcoal and we can melt ice. So let's take a look at our scenario again. When we are burning charcoal, we're producing something that's very complex. We're taking 2 things and we're making 1 thing. We're decreasing the entropy. But if you look at this part over here, This is saying, well, if you decrease your entropy, you're going to have a non-spontaneous reaction. But we can burn charcoal. Well, if we're decreasing the entropy, what's the factor that's going to push this reaction forward? It's because it's going to be highly exothermic. It produces a lot of heat. Yes, we're making a more complex molecule, so that's going to decrease the entropy. However, the exothermic nature of this chemical reaction far exceeds the stability that it creates with making the carbon dioxide molecule, the decrease of entropy. So as long as this exceeds this, you'll still have a spontaneous reaction. Let's take a look at melting of ice. Melting of ice, again, is an endothermic reaction because we're adding heat into it. But endothermic reactions are non-spontaneous. How does this reaction go forward? Well, we have to take a look at the entropy. This process ends up with more chaos and more disorder by melting something. So when you melt the ice, what you have is you have the increase of entropy, meaning we're creating something that's more chaotic. We have the increase of entropy. This far exceeds the case that it's endothermic.